The world relies on energy storage. From powering our smartphones to driving electric cars, efficient energy storage is crucial. Batteries have long dominated this field, but a new contender is emerging: supercapacitors. Supercapacitors, also called ultracapacitors, are energy storage devices. They store energy differently than traditional batteries, offering unique advantages. Imagine a device that charges in seconds and lasts for hundreds of thousands of cycles. That's the promise of supercapacitors. While still under development, supercapacitors are poised to revolutionize various sectors. They hold the potential to transform how we power our devices, vehicles, and even entire cities. Unlike batteries, which store energy chemically, supercapacitors store energy electrostatically. They use the principle of accumulating ions on the surface of an electrode when a voltage is applied. Imagine two conductive plates separated by an insulator. When voltage is applied, one plate accumulates positive ions while the other accumulates negative ions. This separation of charges creates an electric field, storing energy. This mechanism is different from a battery's chemical reactions. Supercapacitors don't rely on chemical transformations to store and release energy. This fundamental difference leads to their unique characteristics and advantages. Supercapacitors and batteries both store energy, but their mechanisms and characteristics differ significantly. Understanding these differences is key to appreciating the unique benefits and limitations of each technology. Batteries are known for their high energy density, meaning they can store a large amount of energy in a relatively small space. However, they have a limited power density, which refers to the rate at which they can charge and discharge. Supercapacitors, on the other hand, boast exceptionally high power densities. They can charge and discharge much faster than batteries, often in seconds or minutes. However, their energy density is typically lower than that of batteries. This difference in characteristics makes each technology suitable for different applications. Batteries excel in applications requiring long-lasting energy storage, while supercapacitors shine in situations demanding rapid energy delivery. The unique characteristics of supercapacitors offer several advantages over traditional batteries, making them attractive for various applications. Their high power density allows for rapid charging and discharging, making them ideal for applications requiring quick bursts of energy. They can also withstand hundreds of thousands, even millions of charge-discharge cycles without significant degradation, unlike batteries, which have a limited lifespan. Furthermore, supercapacitors operate within a wider temperature range than batteries and are generally considered safer. They don't contain hazardous materials commonly found in batteries, reducing environmental concerns. These advantages make supercapacitors a promising alternative to batteries in applications where fast charging, high cycle life, and safety are paramount. Section 5. Supercapacitor limitations, challenges to overcome. While promising, supercapacitors also face limitations that hinder their widespread adoption. Their lower energy density compared to batteries remains a significant challenge. Currently, supercapacitors cannot store as much energy as batteries of the same size. This limits their use in applications requiring prolonged energy storage, such as powering electric vehicles for extended ranges. Another limitation is their voltage drop during discharge. Unlike batteries, which maintain a relatively constant voltage, the voltage of a supercapacitor decreases linearly as it discharges. This characteristic requires additional circuitry for voltage regulation in many applications. Researchers are actively working to address these limitations. Advancements in materials science and design are continuously pushing the boundaries of supercapacitor technology, paving the way for improved energy density and performance. Section 6. Supercapacitors in action, current, and future applications. Despite their limitations, supercapacitors are already making their mark in various sectors, demonstrating their potential to transform energy storage. One prominent application is in hybrid vehicles, where they complement batteries by providing quick bursts of energy for acceleration and regenerative braking. Supercapacitors can capture and release energy rapidly, making them ideal for these tasks. They are also finding applications in portable electronics, powering devices like smartphones and laptops. Their fast charging capabilities and long lifespan are particularly beneficial in these applications. Looking ahead, supercapacitors hold immense potential in renewable energy, grid-scale energy storage, and even public transportation. Their ability to rapidly store and release energy could enhance the efficiency and reliability of renewable energy sources like solar and wind power. Section 7. Advancements in supercapacitors pushing the boundaries. The field of supercapacitors is constantly evolving, with researchers around the world working tirelessly to overcome their limitations and unlock their full potential. Advancements in material science are at the forefront of this progress. New materials with higher surface areas and improved conductivity are being developed to enhance the energy density of supercapacitors. Graphene, with its exceptional properties, has emerged as a promising material for supercapacitor electrodes. Furthermore, researchers are exploring innovative designs and architectures to maximize the energy storage capacity of supercapacitors. Three-dimensional architectures and microporous materials are being investigated to increase the surface area available for ion accumulation. These advancements are steadily bridging the gap between supercapacitors and batteries, paving the way for a future where supercapacitors play an even more significant role in energy storage. Section 8. Supercapacitors and the Future, a Vision of Electrified Progress. As we transition towards a more electrified future, the demand for efficient and sustainable energy storage solutions will only continue to grow. Supercapacitors, with their unique advantages and ongoing advancements, are poised to play a pivotal role in this energy revolution. Imagine a world where electric vehicles charge in minutes, cities rely on renewable energy microgrids, and portable electronics last for days on a single charge. Supercapacitors have the potential to make this vision a reality. While challenges remain, the future of supercapacitors is bright. Continued research, development, and investment in this technology will unlock its full potential, transforming how we store and utilize energy. Section 9. Conclusion: Embracing the potential of supercapacitors. Supercapacitors represent a paradigm shift in energy storage, offering a compelling alternative to traditional batteries. Their unique characteristics, such as fast charging, long lifespan, and high power density, open up a world of possibilities across various sectors. While limitations in energy density persist, ongoing advancements in materials science and design are steadily bridging the gap. As research and development continue, we can expect to see even more innovative applications of supercapacitors, transforming how we power our world. Embracing the potential of supercapacitors is not just about advancing energy storage, it's about embracing a more sustainable and electrified future.